Hope I'm audible. Very good morning, everyone. A warm welcome to you all to the second session of the Sri Lanka AI Challenge. My name is Ginura Adhikari, and I'll be your moderator for today. We are thrilled to have you all join us for this enlightening session on implementing RAG applications and fine-tuning LLMs. This session promises to be an exciting journey into the cutting-edge world of retrieval augmented generation and large language models. We'll be starting shortly. Please take this time to get comfortable, grab your coffee, and ensure your devices are set up and ready for the session. Your active participation will make this session more interactive and valuable, so I encourage you all to stay engaged throughout. Let's dive into the world of AI with our esteemed panelist from Cisco Labs, who will guide us through the intricacies of RAG and LLMs. Without further ado, let me introduce our distinguished speakers for today's session. We have a panel of experts who are leaders in artificial intelligence and machine learning at Cisco Labs. Starting off with Mr. Pasindu Liyanage, tech lead in AI and machine learning at Cisco Labs. We have Mr. Thirupan Roykumar, senior software engineer specializing in AI and ML. We have Mr. Purnima Kaharapitiya, senior software engineer also specializing in AI and ML. Last but not least, we have Mr. Yasinda Samaranayaka, software engineer at Cisco Labs. Please join me in welcoming our esteemed panelists. It's a privilege to have you all here with us. Now, let's move on to the main event. Our esteemed panelists are here to guide us through the intricacies of implementing RAG applications and fine-tuning LLMs. They will share their invaluable insights, real-world case studies, and best practices, offering a comprehensive look at how to build a RAG pipeline from the ground up. This is an exceptional opportunity to learn from the leading experts at the cutting edge of AI and ML, as they impart hands-on knowledge that will empower us to master these advanced technologies. Over to you, sir.
Hi, Ginera. Thank you for that introduction. And hi, everyone. Very good morning to all of you. Very great to see like a really good turnout. I think there's already about 90 participants, so it's really great to see you guys joining in numbers, especially on a Saturday morning. So I think let me share my screen so we'll dive right into it. Let me quickly get my slides up. So sorry guys, just had a small technical issue. Let me share the slides. All right. I hope you guys can see the screen. Oh, good.
Yeah, we can see.
All right, perfect. So today we're going to talk about the basically unlocking the true power of Gen AI with practical applications with the concept of RAG, which is retrieval augmented generation. So this is actually like a really interesting topic at the moment because we from Cisco also has been involved in a lot of.
Sorry, person. Person, I think it's going on presenter mode.
All right, sorry. Hold on. Hmm. What about now?
Yes, it's good now.
All right, perfect. All right, so yeah, as I was saying, we were going to talk about the true power of implementing Gen AI with like practical implementations with the concept of RAG, and like with us also like the team who's here today, Thiru, Purnima, Yasin, all of us, we're from a team called EAG at Cisco, where we work on driving innovation and also driving AI/ML solutions for Cisco Corporation, which is our mother company. So we've been working with a lot of GenAI applications during the past couple of months, and we've sort of gone through like the entire journeys of the challenges you had to face, the issues that you would encounter in certain ways when you try to leverage the full potential of these technologies. So today we're hoping to share that with you guys. So we are gonna do like a very hands-on session where we first teach you guys how we sort of build like a RAG pipeline. Then we're going to also focus a lot on like the actual practical implementations and how we could sort of uh, implement these technologies in like an enterprise environment. So I think that we believe would be very beneficial for you guys because like you guys are also ready to go into the industry just to understand how things work and all. So we want to just give you guys a flavor of that as well. So before we start, I just want to take like 30 seconds and quickly introduce Cisco. I know most of you guys might have heard about Cisco Labs, but just to introduce what Cisco Labs and what Cisco really does. So basically, Cisco Labs is the captive innovation center of a Cisco, which is the world's largest food service provider, which is ranked 54th in the Fortune 500 list. And when you say food service, so what Cisco does in a very high level is that we are a farm to fork company. So like in other words, we're a B2B business. We don't directly deal with customers. We deal with businesses where we collect food supplies and whatever the raw materials that are needed for food service operations from our vendors. And then we manage the entire warehousing and logistic operation. And then we deliver that to our customers. So we work with about 700,000 customers. We are mainly very prominent in USA, but we also operate in 90 plus other countries. And Cisco is like a $80 billion operation, which is quite closer to Sri Lanka's GDP as well. So that's how big Cisco is. And basically, Cisco Labs is the captive innovation center for Cisco, where we enable like all sorts of technology capabilities, and we basically support Cisco's technology operation. And we have about 600 plus different applications that we have in this entire operation. So we basically support in terms of full stack development, data engineering, sort of managing those projects, doing the DevOps, and also we work on the innovation side of it as well. So the ESG team that we are from, we are mainly focusing on the architecture and also the innovation side of it. So we drive like a lot of AI/ML initiatives for Cisco, starting from the e-commerce segment, the supply chain, the logistics, transportation, and all of that. So not just GenAI work, but we do a lot of work related to like core ML capabilities, computer vision. We even work with technologies like IoT and all as well. So that's just like a brief about what Cisco is and what Cisco Labs is, and what our team does. And I think with that, we should be able to get into the session. So today at the session, we're planning to have 6 segments. So the first segment will be like a general overview where we talk about like the present outlook of generative AI space, because we've heard a lot about generative AI. We've seen a lot in like all these different platforms, all these different new things coming up. just wanted to set context where we are in this generative AI space. And with that, we will go into the practical integrations of generative AI. Then we'll move on to the hands-on session. So this is going to be the longest session of the event. Basically, we'll take about close to an hour just to do like a practical implementation where we'll show you guys how we actually build a RAG pipeline, and then we will build it with you guys as well. And then once we're done with that, we will explain to you guys different enterprise level GenAI techniques that we implement for RAG implementations. And also we'll talk about some of the challenges that we face when it comes to enterprise level applications and like very large amount of data that we're handling. Then we'll also go into the model fine tuning part of it, which is going to be another segment where we're planning to take about 15 to 20 minutes and explain basically how you could go beyond RAG and sort of work on a model fine tuning as well. Then after that, we will sort of move on to a Q&A segment where we want to sort of hear from you guys. Like if any questions you guys have, if any feedback is there, if you want to discuss any topics, we will be very happy to take that as well. So I think with that, we can directly get into the session. So first of all, I just want to take you guys through this thing called Gartner's hype cycle. So I think some of you guys might have heard about this before, but for those of you guys who have not heard about Gartner or Gartner's hype cycle, so basically Gartner is basically one of the largest research and consultancy organizations in the world. They work with like very large companies. They work with all the Fortune 500 companies. They provide consultants in terms of technology, in terms of like market research and all that. So this Gartner hype cycle is something that we've been continuously monitoring as people from the innovation side, looking at like all the new technologies that are coming up, all the technologies which are maturing and all that. So this is like every year Gartner actually publishes their hype cycle. So this is something that we usually look forward to, because in this they will talk about all the newest technologies that are out there that are just coming up. They will also talk about the technologies which are like at like a very hyped peak of inflated expectation. Then they will also talk about technologies which are sort of going through like a downward trend, which are sort of getting real and which are sort of going through certain challenges. And then they will also talk about like how those things overcome those challenges. And then they will go into this thing called plateau of productivity, which is like the ultimate stage. So like we all expected from 2022 and 2023, as you can see generative AI was basically the top contender at the peak of inflated expectation. So here what it means is with stuff like ChatGPT coming out, stuff like Llama, Claude, Gemini coming out, generative AI became the biggest thing that sort of came out in the technology space, right? So that was sort of like a technology revolution. Everyone got so excited about it. There was a lot of hype around it. Everyone wanted to get generative AI integrated in their applications. So this was the technology that sort of came out in the past decade, right? But moving forward from this, so with the peak of inflated expectation, moving forward from this from 2020 through 2023 coming in 2024, now the situation is a little different. So we sort of looked at the hyped expectation, we looked at the capabilities, and then we wanted to integrate this technology into our applications. But right now, the situation is not the same. So let's see how it is sort of right now at the current state. So this is actually a video that I just saw last night. I wanted to include this for you guys as well. So this is basically talking about how GenAI enterprise applications are working, especially in 2024 at this very moment. This is very interesting.
Oh, you said this will be ready by when?
This will be ready by tomorrow morning.
What do you mean tomorrow morning?
It's just windows and doors that are remaining. By
What?
tomorrow morning, everything will be done.
But what about the stones?
The stones will be carried right now. You see there is a truck here.
But the truck is carrying the sand.
They are just delivering the sand for a neighbor. This will be ready by tomorrow morning.
Hi,
Pay now. Pay now.
I pay now.
Tomorrow morning, everything will be ready. Trust me, I've been doing this for a long time. Pay now.
Oh, you said this will be.
Yeah, so that is actually sort of the situation that we are in right now when it comes to 2024. Like even though generative AI was such a hype back in 2023, So right now, people are struggling a little to integrate this with actual applications. They are struggling to get the actual value of it because there is a reason for it, right? So even if you look at the Gartner's hype cycle of 2024, you can see generative AI is now sort of in a downward trend where it is moving towards the trough of disillusionment, where it means that now like last year it was like such a big deal. Everyone thought it's going to be like very interesting. It's going to give you anything and everything that you want, right? But now people are starting to realize that it's not as easy as people thought it was to integrate these technologies into our applications. Because now for stuff like ChatGPT, right? Like when you're asking questions, when you're trying to create some sort of a content, it makes sense. It gives the information in like different formats. It gives the information with a lot of creativity. But when it comes to enterprise applications, we want to make sure there's some sort of a structure to it. And then like the problem right now is people are struggling to maintain that structure or like get that structure out of these generative AI models. So that's basically where generative AI is at right now. And that is why it's very important for us to learn these different techniques like RAG, the agents and fine tuning, because those are the things which are going to help you in terms of extracting the true power of these generative AI capabilities. And another interesting thing for us to look at this hype curve for 2024 is that we can see the AI engineering piece has basically become the top content of the peak of inflated expectation. So here what it means is basically this AI engineering concept, this whole thing came about how we utilize the capabilities of these models, which we access through APIs, basically, and how do we sort of use them the right way to get what we want out. So as you can see, that is where the industry is heading right now. And that is where we also have to be. So I think that's why it's very important for us to understand these concepts of RAG and all these agents and all, because that's what's going to help you when you go into the industry. When you start working, that's what's going to help you go that extra mile and get these technologies to work for your applications as well. So yeah, just to talk about like in detail why this is sort of going towards a downward trend. So the first thing is, like as I said earlier, also it's not easy as it sounds. Like people thought this is going to be something that will give you everything, right? This could be integrated to all the applications. You could use this in like all sorts of different frameworks, all sorts of different applications. This will help in all those things. But then when it comes to the actual applications, one thing we realized was for us to make use of this, we have to make sure that these are integrated into our applications, like our existing applications. So to do that, we have to make sure like whatever the outputs that are coming out of these models are in a proper structure, whether it should be in a JSON or whether it should be in a string. Look, those things we have to make sure, because otherwise, like whatever the flows that we have in our existing applications are going to break as soon as we implement these technologies. The second thing is we have to make sure that these are like very accurate, right? Like whatever the outputs that we get, when it comes to ChatGPT and all, it's okay. There are hallucinations that come up. There are instances where it doesn't give the right answer. But we integrate this into our applications. We have to make sure that it always gives us the right and the accurate answer without hallucinations. So that is also another problem that sort of came up with this whole generative AI thing. And the third thing is, it's not quite simple to get exactly what we want out of these models. So like if you want to sort of, get some sort of a deduction, if you want to get some sort of a evaluation, if you want to get some sort of an analysis, there's a way you have to talk to the model with your data in order to get that out. So basically, that's where you get these different concepts of integrating generative AI into your application. So I'm going to talk about three of those models, or like three of those techniques. And then RAG is going to be one of them. So we are going to deep dive into that and understand how that is going to be implemented. So here you guys can see, so the three things that we are going to talk about is basically direct prompting with prompt engineering, and then we are going to talk about RAG and model fine tuning. So if you look at the first component, which is the direct prompting, that is basically you talk to the model. So same as you talk to ChatGPT with like a text query, you talk to the model through an API, but again, like all you pass is your input and the prompt. So prompt is basically like how you talk to the model, like how you sort of address it. So I think this was something that you guys might have gone in detail during the last session as well, and we will cover this in the upcoming slides also. So I'm not going to get into like very in detail explanations of this, but I'm just going to explain the concept of it, right? So when it comes to direct prompting, it's basically you have like an input data where you also have a prompt around it, right? Where you tell the model based on this input, this is what you have to do. where, like, for example, you give some sort of information regarding a product, like for Cisco's, from Cisco's examples, like if you give some sort of information regarding a food product, then you can ask the prompt to use that information and create a description for that particular product. So that's going to be basically one of the examples. Then that input and the prompt will go into the pre-trained model, which could be OpenAI. OpenAI's GPT-4. It could be Google's Gemini 1.5. It could be any of those models. It goes into the pre-trained model. It generates an output and gives you the output. So here also, when you are doing the prompting, there are like different techniques that you can follow, like zero-shot prompting. You have something called few-shot prompting. You have stuff like chain of thought. So these are like different ways that you structure your prompt so that you can get the expected output. So it's not just you sending like something saying, hey, this is my input, give me the output. But you structure in the way you give certain guidelines, you give certain steps, you give certain sort of like narrowings and sort of like disclaimers in order to make sure that you get the output exactly the way you want. But one of the biggest problems here is that when it comes to enterprises, now we want to make sure that whatever the applications that we build are able to give out the latest information that are out there. So one of the biggest problems with that is that if you take pre-trained models, they have been trained on a certain set of data, and then that data basically, so the pre-trained model will have knowledge only up to that level. So if you take something like GPT-4 that came out last year, so that has been trained with data leading up to 2023. So it won't have the latest information out there. So that is one of the problems. The second problem is when it comes to enterprises, again, we don't expose all our information into the internet. So when these pre-trained models are trained, they're basically trained off the data that they capture from the internet. So they don't have the capability to basically know the information regarding our companies. So when we integrate that, people won't be able to ask questions related to our company procedures or company information. So that's also the second problem. So that's where the whole concept of RAG comes in, the retrieval augmented generation. So here what you do is you sort of take it a step further, where you have the same process from input data to prompt, but you bring in something called the vector store or the knowledge base here, where we have the pre-trained model in one side, but we also create something called our own knowledge base. So there we are going to have documents related to like our company's processes, documents related to latest, whatever the news or whatever the information that we want to answer from. So we could have that documents in our knowledge base. So here what happens is when the request or the input data comes in, before you pass that with the prompt into the pre-trained model, you will first go into your knowledge base and see if there's any information regarding this particular question stored in our knowledge base. So we do something called the retrieval. So it will go into the knowledge base. If like, for example, if you ask about like a company's HR policy. So if you have the HR documents here, this will go into the knowledge base, get that information, and then use that information also with the input data and the prompt when it's passing to the pre-trained model to get the response. So now it's not going to be given from the pre-trained model's knowledge, but the answer is going to be given from the information that we provided from our knowledge base, right? So that is basically how the RAG is implemented. Again, this we will go into like very much in detail how this works. And then the problem with this is now when the knowledge base increases, now like for a company like Cisco, we have like close to about 60,000 employees. We are operating in like 90 plus countries. So if you think about like an HR application, we are going to have like hundreds and thousands of documents which work for different countries, different regions, and different organizations inside Cisco. So then when that knowledge base increases, it becomes a little tough for the RAG to also comprehend the questions, right? There could be certain instances where there are certain relevant information in multiple segments which has to be picked up and the answer has to be created based on all of that. So that way RAG also could be getting complicated at one point. That's where you have to move towards the model fine-tuning. So model fine-tuning, what we do is, again, you sort of have the pre-trained model, right? Like you did with the previous instances, but you take the pre-trained model, you take your data. So now you don't put the data in a knowledge base, but you take your data and you basically create a data set out of it. So if that's in a PDF or if that's in like a Word document, you take that data, you create a data set out of it in sort of like a question and answer form. Then you use that data to fine tune your pre-trained LLM. So now what happens is the model will have its own knowledge, but it will also have the knowledge about your company, about your company's HR policies. So now when you ask a question from the fine-tuned model, that is going to have that knowledge in the model itself. So it doesn't have to go and do the retrieval and find the relevant information and all that, but it can directly answer. So fine-tuning in terms of implementation, in terms of quality of response, it gives you like really good results, but it could also have certain limitations. So I think like when it comes to like model selection, when it comes to selecting the best thing that you want to use, it's basically about like how you sort of look at your use case and how you sort of get the best mechanism that is suitable for your use case, where you can get the maximum out of it, right? So that's basically the three most important things that we are going to talk about today. But there are other methods like agents, basically generative AI agents. So this part comes in where you don't just want to get some information out of it, but you also want to do certain actions. So not just you retrieve information, but you want to call APIs and get information. You want to call database queries and get information. That's where the agents come in, right? So as you can see on this arrow, starting from left to right, obviously the quality of the responses are going to be much better. But also something that you have to keep in mind is that this is going to be more complex when you're doing the implementation. So it's always going to be like a trade-off, looking at your use case and looking at the amount of accuracy and amount of complexity that you want to handle. You should be able to select the right option, right? So before we move on to the next section, just want to check with you guys. So now we have all these three options. Would you guys be able to just quickly maybe give me a couple of examples where we can use direct prompting, where we can use drag, and where we can use model fine tuning? Just it'll take like 1 minute just to quickly see if you guys can maybe also come up with like some of the projects that you're already working on, like some of the things that you have in mind.
I think personally we got one question from Ahmed.
Okay.
It's asking to explain the difference between fine-tuned models and pre-trained models.
Right. Okay. Yes. So guys, when it comes to pre-trained models and fine-tuning, what happens is, so the pre-trained model is the base model. Like, so whatever that you have in ChatGPT, GPT-4, that is a pre-trained model. So if you take Gemini 1.5, that is also a pre-trained model, which has been trained with like, you know, certain amount of parameters. There's like 70 billion parameter models. There's like 8 billion parameter models. So they've taken like a certain set of data and they've trained the model on that data. So that is going to be the base model that we're using ChatGPT. When you call ChatGPT, that's going to be the base model you'll be using. And if you call Gemini, that's again going to be the base model that we use. But the problem is when you ask a question related to your particular organization or your particular company, this model will not have that information, right? Because it has been trained on publicly available data. So it's not going to have any particular information regarding a particular organization or a particular company. So fine tuning means you get the base model, which is already trained, because it already has a certain amount of information. The architectures are properly in place. The training has already been done for certain amount of parameters. But you also bring in your data, like whatever the information regarding your company or your organization, then you add that data also into that model. So that is where the fine tuning happens. So it's not basically creating like a complete model just with your data, because that's going to be very complex. You need to have a lot of data. You need to do a lot of processing. You need to, you know, set up architectures and everything. So you don't have to go through that entire process of creating your own model from scratch, but you take the existing pre-trained model and you give your information onto that by creating the data in a particular format, which we'll show you guys at the last segment. And then you get the fine-tuned version out of it. Does that answer your question?
Yeah, thank you. Thanks a lot. It basically means initially we are taking a generic model and feeding our own specific data to that for fine tuning, right?
Yes, correct.
Okay.
So we have to prepare the data in a particular way. We will show that to you guys in the last segment, but that is basically the high level idea of it.
Thank you.
All right. Anything else that you guys want to clarify before we move on to the next segment? Yeah, I see you guys basically posting some ideas in terms of different areas that we can implement these technologies. Yeah, this looks pretty good. And
I think TW had asked, his name goes as TW, I'm not sure what it means, but he has asked whether we are going to be using 2 models in the whole RAG chain pipeline. Yeah, that's correct, TW. So you'll need one model for the embeddings and you'll need another model to make sense of that embeddings and basically generate out the answer to your question.
yes. So that full workflow, guys, we'll show you guys in the next slide. So here, just wanted to give you like an overall idea about these 3 different plays, but we'll deep dive into each of these things and understand how these things really work.
So another question by Maza SMM. Fine tuning we're discussing, is it PFD or the original fine tuning from the base model? Yeah, we'll be doing a PFD one, Mazar, because we'll get into detail, but for now we'll be using specifically LoRa with PFD. We'll be using LoRa.
Yeah, so I think most of the questions are related to like the next segments that are about to come. So what I'll say is we'll move on to the next segment with the time also, and I think we can take the questions probably at the end of each section. So that way, I think we would be able to handle the time better as well, right? So let's move on to the next section with that. Yeah, so here, guys, now for these implementations, we are going to do a RAG. Basically, for RAG, we are going to do a hands-on workshop. So today we'll be using Google's Vertex AI platform for this. I know, like usually you can use stuff like OpenAI, you can use Claude, you can use Llama 3 if you want to sort of work on the open source space. But today we'll be doing this practical experiments using the Vertex AI platform. So there are a couple of reasons for it. So one thing is Google's Vertex AI platform has really transitioned into like a really great state during the past couple of months. They've introduced like really great features, especially for developers who are using this generative AI capabilities and integrating them into enterprise applications. They've implemented stuff like response schemas. They implement stuff like groundings and different sorts of techniques which we can use for applications. So we will walk you through this particular technology for today. But since we are using an orchestration framework, you can use whatever the generative AI model. It could be OpenAI's ChatGPT. It could be something else, like whatever that you guys want to use, that could be used. But for today's session, we will mainly be focusing Google's Vertex AI platform, right? So Vertex AI platform is basically Google's sort of like AI ecosystem, where you have not just generative AI stuff. You have your workbenches, you have your notebooks, you have your training environments, model ops pipelines, and everything. But the generative AI studio here is like very advanced. They have like a lot of different capabilities. They have a very large context window as well, where we can pass 2 million tokens. And they have features like context caching. They also have like advanced features like prompt evaluations as well. So let me quickly show you guys how Vertex AI looks on GCP, and then we can go into the RAG building pipeline. Let me quickly share my screen again. I hope you guys can see the GCP console.
Yep, we can see first.
Perfect. All right. So when you go into GCP console, so one thing is, guys, like as university students, so one of the biggest problems I know you guys are having is that when it comes to these enterprise services, there is a cost associated with it for you guys to use the certain APIs and all that. But with GCP, one of the great things they have is when you create a new account on GCP, they give you $300 in credit. So like if you guys want to sort of play around with this, understand how these APIs work and all, you guys can create a GCP account, and you need to add a billing account to it. You basically have to put your card. But once you do that, it's going to give you $300 in credits. But make sure that you are constantly monitoring the credits usage, because if you spin off some sort of a service which consumes all the credits, it's going to charge you. So make sure that you continuously monitor that, but you're going to get the $300 where you can play around and try out certain things. So when you go into GCP console, this is basically where you go into, and then when you search for Vertex, you can get navigated into the Vertex AI platform. So this is basically how Vertex AI platform looks like. You have like all the different capabilities on Vertex AI. You have the notebooks. You have something called the model garden, where you can take in a lot of different models into your applications and all that. But the interesting part for us is this Vertex AI Studio, where you have like language models, vision models, where you can generate images. And you also have stuff like multi-model integrations, where you can use stuff like Gemini 1.5 Flash and 1.5 Pro for your applications. So just a couple of things is that now, if you're trying to integrate this, one of the easiest ways to do the integration is that when you go here, you can basically get the code for the integration from here itself. You can select whatever the language that you like, whether it's Python, Node, Java, or you can even take the curl out of it. Then it's going to give you a sample code, which you can integrate in your project and basically start using this application. So one thing to notice is, guys, now, if you want to use this in your applications, you have to basically authenticate that service. So just like you do with OpenAI, you have to have an OpenAI token or like an OpenAI key to authenticate. So the same way, you need to have a Vertex AI service account as well. So I'll quickly show you how we create that. And then for this particular session, we will share a service account with you guys. But if you guys already have created accounts by any chance, you guys can also do this. So you can try it out from your account itself. So in order to create the service account, you just have to search for service account, and you will go into this page where you can create a new service account. You can give a name for it. Just call it AI-driven Sri Lanka. And then you have to grant permission for this particular service account to access your Vertex AI services. So here you have to select Vertex AI Administrator, which grants your service account to access all Vertex AI capabilities. Once you're done with that, you just have to click on done, and that will create the service account for you. Done. Yes. It will create the service account for you. And then once the service account is created, you have to go and create a service account key for that. So here you have something called manage keys. So when you click on that, you'll go into another page where you can create a service account key. Here you click on add key, create new, and then you get the JSON out. Right? So once you do that, JSON file is going to get downloaded. And then that can be used basically to authenticate from either your notebook or either your local code base or from like a different, like AWS environment, from like Azure environment. If you want to use GCP services, you could use this method. So there's another way that you can use it in local machine. You can authenticate with the G-Cloud authentication. That's also another way. We will share the resources for that. But we will use this method because we'll be sharing our service account key for you guys to use today. We will basically share that with you guys in a bit when we start the practical session. So that's basically about Vertex AI and how to create the service account. So if any of you guys have created the account, please make sure that you get this step also completed so you can have your service account JSON ready for the practical lab. And yeah, I think with that, we can move on to the practical session. Thiru, over to you.
Thanks, Prasan. All right. I hope you can see my screen, right?
Yeah, Thiru, we can.
All right. All right. So I hope you guys now got an idea about what is RAG and why we are going to use RAG. So that the importance of RAG rather than like directly invoking the large language models. So let's start deep dive into the retrieval augmented generation, the RAG model. So as you all know, the RAG consists of two main parts. One is as the RAG stands for retrieval augmented generation, it has the retrieval part. So where you will have a bunch of documents, and based on your query, you will retrieve the relevant context. And then you have the generation part where you will have the retrieved context plus the question to generate an answer based on an LLM. So let's deep dive into the solution overview of this. So let's say you have a few documents that you wanted to like build a chatbot on top of it. So let's say you have a PDF file, so whatever the other CSV file formats or anything, you have a few documents. So maybe during the explanation, I will divide the RAG architecture into two main parts. One is the data ingestion pipeline and the RAG pipeline. All right, so first we'll look at the data ingestion pipeline. So we have a bunch of documents. So first, as the first step, what we'll do is we will extract the content out of these PDF documents, and then we'll split them into small manageable chunks. small manageable chunks. So this way, like let's say you have a PDF of around maybe 100 pages and so on. So then you will have chunks of text maybe with the word number of count around 500 words per each chunk. And then for the each chunk, we will have to convert them into embeddings. So embeddings means it's kind of a numerical representation of the paragraph that you have chunked. So the use of making the embeddings is like let's say you are doing a search on a PDF like a traditional keyword search. So in that case, there is high likely you will get a result if the exact keyword is present in the document, right? So otherwise, maybe a close variations of the keyword you might get. So why we are converting this text into an embeddings is that like these embeddings can have the semantic relationship in between the chunks. So this way, like if we have a query, we can easily like get the most relevant chunks because it keeps the semantic relationship in between them. And then finally, like once we convert all these chunks into these embeddings, then we'll store them in a vector database. So this concludes the first part, the data ingestion pipeline. Now we look at the RAG pipeline. So let's say we have created the embedding vector database, and a user comes and asks a question, right? So as the first step, what we'll do is we will convert the question also into a vector embedding, like the embedding model, the same embedding model that we have used previously. We'll use it here also, and we'll convert the question into a particular vector embedding, and we will search through the embedding database, like what are the other vector embeddings that are like that are closely located in the vector space. So like you can think of it like as these embeddings, you can think of it like as a 3D three-dimensional vector space. So these each chunks will be positioned in certain places. So once the query comes, we will only pick up the topmost closely located embedding vectors. So thus it will like directly aligns with the question, and it will mostly contain the relevant information about the question. So first we will from the vector database, we will retrieve all the relevant topmost the chunks. So right now we have the relevant chunks plus the question. Then we will send both into the large language model, and then the large language model will generate the response out of it. So this is how the RAG pipeline works. And maybe I'll explain a bit more on this embedding side. So as I said previously, like so I will explain a few key components in this track. So one is the embeddings generation. So as I previously said, this embeddings is like let's say we have a sentence or we have a chunk of paragraph. So like this embedding generation, what it does is it converts the text into a numerical representation in which it has the semantic relationship in between other chunks. So in this first example, you can see the two words are like striped blue shirt made from cotton, and also cotton made maritime shirt. So we know from our understanding, these both sentences refer to the same thing, right? So if you look at once we pass through the deep neural network, which is the embedding model, so we will get the embedding vector. So this is what we call as the embedding vector. And for the other sentence also, we got this particular embedding vector. So if you closely look at, so both embedding vectors kind of equal, right? I mean, here, if you look at it's 0.1, the first embedding vector, sorry, and it's 0.1. So likewise, if you look at the entire vector, both are kind of similar. So that means in a three-dimensional vector space, these both sentences will be closely located. All right, so that's the basic idea of this embeddings generation. So this embedding generation is not only limited to the text-based content. Like even if you wanted to like create embeddings for images, you can do that. Even for audios and everything, you can like create embeddings using embeddings model. So like for in this particular case, if you want to like create embeddings for images or documents and audio, like instead of using a text embedding model, you can go for a multimodal embedding model, and you can create the embeddings. So this is a picture which shows in a 3D in a three-dimensional space how these vectors are being located. So yeah. So but in this particular session, we'll be only focusing on the text-based embeddings. So we'll only considering the documents and so on. So like in other cases, like let's say if you wanted to build an image search application, you can easily do with this particular flow. Like you can create embeddings for images, and you can get an input image, and you can convert that also into an embedding, and you can in the vector space, three-dimensional vector space, you can search for closely located image embeddings, and those image embeddings will be like directly translate to the similar looking images. So you can build applications like that also. Here we will only focus on the text-based embeddings, and because we'll only use the documents for our chatbot. All right. So next, let's look at the similarity search. So as I previously mentioned, so in a three-dimensional vector space, like each chunk will be located in different places. So if you look at here, like the banana and apple, those vector, I mean, those vector representations are closely located, right? Because they carry a semantic relationship in between them. So because those falls under the category of fruits, they have a semantic relationship in between them. So that's why those are closely located. And even if you see Google and Apple company, so they are closely located as it carries the semantic relationship as tech companies. So you can see that the Apple company and the actual fruit apple are not closely located, because I mean there's a bit of distance over there. So that defines there's a difference in between how the semantic works, right? So I hope now you got an idea. So let's say now, so in the chatbot, how it works is, let's say a user comes and asks a question, and first we will convert the question also into embeddings, as I said previously. And in the vector space, let's say this is the query. So we have used the query as kitten. So it will convert the embeddings, and in the vector space, it will look for what are the other embeddings that are closely located, which are generated before. So if you look at for this particular query kitten, you can see like there are other maybe other species of cats which might be closely located in the vector space. So while we are retrieving the topmost relevant the context from this particular vector space, I mean whatever that matches close to cat will be closely located, and when we are retrieving it, we will retrieve only those particular related content. So this is how it's going to work. We'll have the query and the relevant document that we are going to refer when generating the responses should be the closely located vectors. All right. So now, so next I'm going to show you a hands-on session on how to build a RAG-based chatbot. So for that, we have to like decide on certain technologies that what we are going to use. So I think I have seen a question also, like do we have to use separate models for embedding and for the response generation? Yes, we have to. So if you look at, I have 4 different categories to do the technology selection. So we need to decide on an embedding model, and we need to decide on a vector database that we are going to use, and a response generation large language model. And also I'll talk about the frameworks. So first, if we look at the embedding models, so we have already like there are so many embedding models out there. So in this particular session, we'll only using the Vertex AI embeddings model. So in the Vertex AI, if you look at, there are a lot of embeddings, like the text embedding Gecko at 001. So like that, there are several versions of it. Let's say like if you have documents with multiple languages, then you might have to opt for the text multilingual embedding. So in that way, it can capture the multilingual semantic relationship in between it. But in this particular session, we will only consider the documents which are in English. So we'll only use the normal text embedding model. And also, like if you wanted to, like as I said previously, if you wanted to like create embeddings for images, or if you wanted to create embeddings for audio and everything, you can opt for this multimodal embedding, right? So these are the offerings from the Vertex AI. So in Hugging Face also, there are so many embedding models available, like the sentence transformers and so on. So even OpenAI, you can, I think they have provides these OpenAI embeddings model. So that's about it. And if you look at vector database, the open source one, and which is a free one that we can use locally, is the Chroma one. So we will use it for the session. And there are other vector databases also available, like Pinecone database, and even other the topmost cloud providers like Azure, Google, and AWS. They also provide their own vector databases. Like for Azure, you can see Azure has its own Azure vector search, and also Google has its own Vertex AI search, and AWS has Elasticsearch and OpenSearch. So there are multiple vector database options available. So in the session that we're going to do, we'll only focus on the Chroma. And then if you look at the large language model for response generation, we will use the Gemini 1.5 Flash by Google. I mean, if you want, you can use ChatGPT or Llama or even some other models which are available in Hugging Face as well. And then about the LLM framework. So first I'll give an introduction of the LLM frameworks. So these LLM frameworks, what it will do is it will easy our development effort, whatever the workflows that we have to create around this natural language processing, or specifically these regarding about these RAG-based chatbots. These LLM frameworks made it easy for us to integrate with whatever the embedding models or whatever the large language model that we are going to use. They made us the code part implemented up to a certain level. So they have abstracted the code and built a wrapper on top of these particular models so that we can directly use some of their libraries and we can directly implement them. So this is kind of a wrapper, a helpful framework which we can use to deploy generative AI, especially the RAG-bot applications. So if you look at, there are multiple options available like LangChain, Llama Index, and Haystack. So in this particular session, we'll only focus on this LangChain framework. Right. So that concludes, the basic introduction of the RAG-bot and how we are going to implement it. So now let's move on to the practical session of it. So we already have the notebooks ready and all, but we wanted to do with you guys. So feel free to if you have any questions, feel free to ask us, and also please whenever I'm doing the coding part and working on it, please do it along with me as well. So first, I hope everyone worked with Google Colab. So we'll implement the pipeline, the RAG-based chatbot in the Google Colab. So can you guys please open Google Colab in your machines, and we will work through the process. So once you get into this particular window, click this new notebook. And yeah, there you have the notebook. So rename whatever way you want. Maybe I'll give you a minute or so that you can also open up a Colab notebook and be ready with me. Maybe I'll give a minute for you guys. All right. So I have divided these into subsections. So first I will walk you through authenticate the Colab notebook to the Google Cloud Vertex AI platform. And then we will create the first part of the pipeline, the data ingestion pipeline for the RAG chatbot. And then we will work on the response creation part. So after every section, I'll give you some time also, and I'll also share the code in the chat so that you can also work on it. But if you want, you can execute the code while I'm doing also, sir.
Excuse me, sorry for interrupting.
Yeah.
Do we need a high computational power for this, or just a normal machine is enough?
And like the normal one is enough. You don't have to select any GPU version, runtime or anything. The normal version would be fine.
Okay, fine.
So, all right. So in the first part, we'll be looking at authenticating the notebook to the Google Cloud Vertex AI platform, like in order to interact with the Gemini 1.5 Flash or the Vertex AI embedding models. So as the first part, we'll work on this. So actually, there are two options that you can authenticate, maybe like outside the GCP environment. You can authenticate the Google Cloud AI platform. One way is to use these application default credentials. So there you can, like, let's say you are working on a local environment. So you can use this Google Cloud Auth login, and you can log in your Google account, and then you can use this particular Vertex AI platform. And the second option would be to use the service credentials, like the person you mentioned before. You have to create the service account credentials, and then you can work on them. So in this particular session, we will use the service account credentials. We'll be sharing those credentials with you as well. But if you have your own credentials, please use them. If not, you can use the ones that we will be sharing. Personally, can share the service account, the JSON file in the chat?
Sure,
Yeah.
I'll share it.
So with the interest of time, we'll quickly. So since I have the notebooks ready, but anyway, I'll quickly copy and paste the command, and we'll quickly move on forward. Anyway, I'll explain step by step what we are doing here. So in order to interact with this Google Vertex AI platform, we need to install certain libraries like Google Cloud AI platform. And also, as I said, we'll be using the LangChain framework in order to interact with it. I mean, the different models and so on. So we'll install this particular LangChain Google Vertex AI as well. So first we'll execute this. All right. So it's done. So then now, we are going to use the service account credential files. No. So the usual process is to save them in the environment file. So in order to load the environmental file, we have to install this particular Python.environment library. We'll install that as well. Then we will need since we install this Google Cloud AI platform, so we have to import these particular libraries like the AI platform from Google Cloud, and from Google Auth2 we'll import the service account, because we are going to authenticate using the service account. Also, we will import the Vertex AI. The Vertex AI generative models. From it, we'll import the generative model, the safety settings, and all. And also, we'll that's about it. Okay, so now, all right. So now, if you click this particular the folder icon, you can see the working directory. So first, we will store the credentials file in this particular directory. So right click and click new file, and maybe name it as Vertex AI config.json. And double click the file, and so here you will paste the service account key that person is shared in the chat. I'll also use my one. All right. So the service account key will, the credential file will look like this. So save it here like this. All right. So once done, like if you want to look at the current working directory of this particular notebook, let's run the pwd command. So we are in the /content, right? So in this particular directory, so next we will set the environment variable. We'll import the OS, and then we'll set the environment variable. So it should be set as Google application credentials, and then path to your Vertex AI config JSON file. Because we are in the currently the working directory /content, and then the Vertex AI config JSON file. Once done, you can execute the cell. And then like we will load, like from the service account, we will load the credentials. So this is the credentials path. So we'll pass it on to the service account thing, and we'll generate the credential, like we'll load the credentials. And then we will initialize the Google Cloud AI platform. So we'll use the command AI platform.init, and we have to, so here we have to pass the project ID. So if you look at the configuration here, the project ID is what you have to pass here. So here it is AI driven Sri Lanka. So you'll pass the project ID here. And then in the location parameter, so there are multiple locations available that you can select. Maybe for this particular use case, select this US Central one. And also in the credential, pass on the credentials that you loaded before. So once done, execute it. Right. So that's about it, about authenticating the notebook with the Google Vertex AI platform. Next, we will look at the direct prompting. Maybe in the meantime, like maybe I'll share the code in the chat as well. So if you want, you can do the first.
Yeah, the code
Yes.
audio.
Yeah, share it. All right. Good.
So maybe we'll give like a minute for everyone to come to this stage, and then we'll move to the next stage.
Yeah, sure. Then I'll wait for a minute.
Yeah. So guys, all the codes are there in the chat. You guys can copy that and you can run it in your Colab environment. If you have any questions, you can ask here, or you can drop that on the chat. So we'll answer while Thiru is doing the session. Yeah, I think maybe we can continue, Thiru.
Right. All right. So as the next part, we'll be looking at testing the direct connection between the Vertex Gemini 1.5 Flash. So like this would be more of like asking questions in ChatGPT, but instead of ChatGPT, we'll use the Vertex Gemini. So we haven't built anything on anything related to REC up until now. So we'll just ask a question and see how this the Gemini 1.5 Flash model responds, right? So for that, we'll first initialize the vertex like by passing the same. So this particular vertex is from LangChain. So like we have to again pass the vertex, the project ID and the location. And also we will create an instance of model, which is the generative model, that the library that we have previously imported. And we will set the model name as Gemini 1.5 Flash. So then the next step, we'll ask a question to this particular model and see whether it has the answer, right? So we will ask a question like, what does IEEE stand for? And we will, let's look at the response that it gives. Sorry, I think I did not execute this one. All right. So if you look at the response it gives is IEEE stands for Institute of Electrical and Electronics Engineers. So that's correct. So if you look at the response, the response is generated by the role is set to model, and in the text you can see the response. And there are a couple of other things also in the response, like the safety settings. Like if you wanted to filter the response based on some safety setting, like if you want, if there's any hate speech, you can like filter the response, or like if there's any dangerous content or harassment or anything. There are safety settings available in this particular model, so that you can even like preset them. And in the responses, those like if there's any hate speech detected in the response, like it will automatically filter out, and you won't get the response. I mean the hate speech response, right? So those options are also available for you to use, right? So I think if you look at what does IEEE stands for, I think it gave us the correct answer. So let's ask a different question and see whether it answers. So here I'm asking a question. This is not a generic question. This is more of IEEE student branch in Sri Lanka, right? So I'm asking a question: when is the annual plan due for IEEE student branch Sri Lanka? And let's look at whether Gemini knows the answer for this particular question, right? So if you look at it gives the answer like I do not have access to the real-time information, including the specific deadlines for IEEE student branch Sri Lanka. So that means one, maybe the IEEE student branch related information is not there in the Gemini, or else, I mean, it couldn't identify, like find the answer based on the knowledge base it's been trained on, right? So here we saw the limitation, and that's where the rec comes to fill up. So like maybe I'll show you a document that which we are going to use for this particular track model implementation. So as you're aware, for this particular question, the large language model Gemini does not have the answer. So now we are going to build a RAG pipeline, and we are going to see how that particular chatbot can answer this particular question based on the knowledge base, right? So we will use this particular document, IEEE Student Branch Officer Training 2019. So it has around 16 pages. So we'll build a chatbot on top of this particular document, and we'll ask questions from this particular document and see how it responds, right? All right. So this comes to the second part of the section. So I think, guys, if you haven't done the steps, you can do them right now. I'll wait for a minute here. But in the meantime, you can share the code, right?
Yeah, I'm sharing the code with you.
All right, cool.
And guys, also you might sometimes get a error with a quota exceed error, because I think we have about 150 people here, and Gemini usually has a quota limitation where there's a number of requests that can go into the model per minute. So I think you guys might get that error when you're trying it out with the service key that we've given. If that is the case, maybe you can try changing the model. You can try Gemini 1.5 Pro and Gemini 1.0. I'll put the two models also into the chat. So if you are getting that error, maybe one thing is you can try like after a little while, or you can change the model and try also. But that is something that we will face because we have a larger crowd here.
I hope you guys did until this step. And even if you missed any of the steps, or if you face any troubles, don't worry. Like at the end of the session, we'll be sharing the notebook with you guys, so you can even work. But we'll recommend if you face any issues, please raise, and we'll build a report during the session itself. So the second section that we're going to look at is creating a knowledge base. So that's what I have explained before, like the first part, the data ingestion part that we're going to do. So we will use that particular IEEE student branch PDF, and we will work on chunking them and creating embeddings, and then storing them in the Chroma vector database. So we will do that step right now. For that, first we have to upload the particular PDF into the working directory. So So what you need to do is right click and create a new folder and name it as maybe data. And inside it, upload the particular file. Person can share the file also in the chat.
Sure, will do.
Okay. And so inside the data folder, we'll upload the file. So once uploaded, so inside the data folder, you can see the particular file, right? So, all right, so let's move on. So first, we'll import the necessary libraries. So since we are working with the PDF files, we need to install this PyPDF file to like extract content and all. And also, I have mentioned about this LangChain before. So this is the framework that we are going to use, which is going to ease the workflows that we're going to create during the pipelines and everything. So it has a wrapper around it, and we can easily create them without having to like code from the scratch. So we'll use that particular framework as well. All right, so we'll first install them. All right, now it's installed. So then now we will like import the libraries from whatever that we have installed previously. So from the LangChain, we will from the document loaders.pdf, we will import this particular class PyPDF directory loader, because from this particular directory, we need to load the PDF files which I need. And then we'll be like importing this particular library in order to like split the PDF into smaller manageable pieces, like the chunks or small paragraphs. So we'll use this recursive character text splitter, and also like to load the PDF to have the schema, like the page content, the page numbers, and so on. So for that, we'll use this particular LangChain schema. We'll import this particular document class as well. So for that, and now we will load the PDF file. So first we will define the data path. So as I previously mentioned, the working directory / content. So inside it, we have this particular data folder. So we'll set that as the data path. And then we'll write a function called load documents. We will use the PyPDF directory loader library that we have initially imported for this one. And we will pass the data path into that particular function. And it will load the documents and return it. So let's put that next. So now we'll run this particular the load documents function, and also let's have a look at, and we'll do a print statement, and let's have a look at a particular instance of this document. I mean the output which is being loaded. Right. So in this particular thing, you may see like we have loaded the documents, and if we print a particular, I mean this is going to be a list. In this particular list, we'll only print out the element at the first index. So if you see, it has page content. So the PDF files I shown you. So from here it shows the page content, and then as the metadata, it has the source. I mean, from which PDF this content is being from. So because for each chunks, we need to have those the metadata tagged into it, because later in the retrieval process we might need them. So it has the metadata and also like the page number in which it has like loaded this particular content from. So this is how it will look like when we load the documents.
Till maybe let's give another minute.
All right, sure. Yes, I'll give you another minute.
In the meantime, if you have any questions, do ask. I hope all of you guys can download the document as well. It's there on the chat. So you can use the same document if you like, or if you can use another, I mean, you can use another document as well. But the document that we are using for this particular experiment, that's there on the chat.
All right. With the interest of time, let's move on a bit faster. So since now we loaded the documents, like we have loaded the page content and everything. We have extracted the text from the PDF, and we have loaded the document. So now the next step, we will look at splitting the documents into smaller manageable pieces. As I mentioned previously, like into smaller chunks, we will split them. For this particular purpose, we will use the recursive characters text splitter library. So I mean, like from LangChain we have earlier, like we have imported that earlier as well. So we'll use this particular function. So like in this particular recursive character text splitter, like we can define certain parameters like the chunk size. So that means like for each chunk, how many characters that we have that we are going to incorporate. So in this particular example, we will define the chunk size as 500. So maybe like so it will be like for each chunk we will have around 500 characters, right? And then we will define a chunk overlap as well, because like we wanted to maintain a shared context in between the consecutive chunks, right? So like so if you divide exactly in the chunk sizes, like there might be instances we will lose the continuity in between chunks. I mean in the consecutive chunks. So we will define a chunk overlap as well. So it will so in the consecutive chunks there will be an overlap of 100 characters. So in that case there will be a continuity over there. And also we will define a length function. So this will be the default Python length function. Like length function is to like calculate the length of each chunk. So it will be the default length function. And also we have the at start index true in order to like flag. I mean, whenever we are chunking, this will have a flag added to each chunk. So that's about it. Then we will in the text splitter function, we will pass on the documents that we have previously loaded. And so this function is going to return the chunks out of it. So right now, execute this split text function. So here, if you can look at split 16-page documents into 82 chunks, right? So if you look at this particular PDF had around 16 pages. So all of those pages have been chunked in, like have been converted into 82 chunks, with each chunk has around 500 characters. So now we have splitted the document, I mean the page content. Maybe like if you want to have a look on a particular chunk, you can. So since it has 82 chunks, maybe let's print a particular, like maybe the index 20th chunk, and we'll see how the page content and how the metadata associated with this particular chunk look like. So if you execute this cell, like you can see, so this is going to be the page content. I mean, this is going to be the particular chunk from that PDF file. And also if you look at the metadata, it has the source, like from which document it got the particular chunk. And also like it has the page numbers and the indexes as well. So it's just to like have a continuity. So it has the metadata and all the page content added to it. All right. So the next part, maybe I'll give you guys a minute so you can work on this as well. All right, so now we have loaded the documents and then we have splitted them into chunks. And the next part, as you can see, we have come up to this stage. And the next part is going to we are going to convert each chunk into an embeddings, like the vector representation. So we'll do that next. So first for that, we have to install the Chroma DB as well, because like after creating those embeddings, we are going to store them here. First, we'll install the Chroma DB. All right, it's been installed. Now let's import some other libraries, because as I said previously, for the embeddings model, we are going to use the Vertex AI embeddings. So we will import it from the LangChain framework itself. And then also we'll so the LangChain also has a wrapper around it for the Chroma from like using the vector store. So we'll import that as well. Next, we define the vertex embeddings. So if you look at this particular vertex AI embeddings that we have imported from LangChain, so we'll have to pass on the model name, so which model that we're going to use. So as I mentioned previously in the technology selection, we will be using this particular, the text embedding echo at the third version of it from Google to create embeddings for our chunks. And then we have to set this Chroma, the Chroma vector DB path as well. So you can set whatever the path you want. So I'm setting this particular path to save the embeddings plus the chunks into this particular vector database. So then we have this save to Chroma function where we'll pass on the chunks. So what it will do is first it will check whether there's an already existing Chroma DB. So if so, it will remove it. And then from the documents, if you look at this particular function, Chroma from documents, we will pass on the chunks that we have created earlier. And also we will pass on the embeddings instance that we have initiated here using this text embedding model. And also we will pass the directory which we wanted to save both the chunks and the corresponding vertex AI embedding. So we will save them with this particular function. Right now I'll execute in sequential manner. So as you see, we have already defined the load documents function and then split text function and now save to Chroma function. So we'll execute them sequentially. All right. So this tells saved 82 chunks into content Chroma. So if you look at, there's a directly created the name of Chroma, and there you can see the vector embeddings and the chunks being saved inside. So now we have came until this stage where splitting, convert them into embeddings, and finally store them in the vector database. So in the next step, we will look at the second part of the pipeline, which is the rack. So in the meantime, you can work up to this point. You can execute the code. I hope the code being shared in the chat, so you can quickly execute and come up to this level.
Yes, Thiru. So guys, I think this is actually one of the most important parts when it comes to RAG implementations, where you get your knowledge base, you break it down into smaller pieces. If you have documents of 100 pages, you break it down into smaller pieces and then you store it in the vector store. So this is actually one of the most important parts. So if you have any questions, any areas that you are not clear, bring that questions out as well. So we can talk about them and clarify them before we go into the next level. Because if you understand this part properly, I think the next section will also be much easier for you to grasp.
All right, let's move on to the third section of it. So in this particular section, what we like, since we already created the vector database and stored the embeddings there, so in this part, we'll be focusing on querying the vector database for relevant context. I mean, if you ask a question, for that particular question, we have to find the relevant context out of the vector database, right? So we'll be looking at it right now. For that, we have to import this particular, the chat prompt template. We'll import that, like for the prompt configuration. So, and then we'll define a query also, like so we came up with this question because the answer for this particular question is within that particular the PDF. So let's see whether it answers the same question that we asked before, like, I mean, in Gemini 1.5 plus, and it said it don't have the answer to this particular question. So let's see whether our RAG chatbot answers the question based on the knowledge base that we have created. So we will define the query as well. And now we will define the prompt template. So in the prompt template, like we'll define it as, so it's kind of a natural language where we will define like how the model should respond to our query, right? So here what we are mentioning is answer the question based only on the following context, and we'll have a placeholder for context where we will pass the relevant context here. And also we have another placeholder for the question to pass on the query that we have here. So we execute that as well. All right, so now we have prepared the prompt and also we have the question. So let's look at what are the relevant contexts that are in the vector database. So for that, as I mentioned previously, the question also we need to convert it into the embedding. So like again, we will load the vertex embeddings instance. Like we'll name it as the embedding function. And so in the chroma, like we will initiate the chroma as well, like we will say, give the path to the chroma DB. And also as the embedding function, we will pass the vertex embeddings that we used before. And also like from LangChain, we can use this, like, I mean, the particular function similarity search with relevant scores. So what this particular function is going to do is we will pass on the query. First, it will convert the query into embeddings, and then it will look for closely located relevant context based on the query. So here we have pass k equals 4. That means like the closely located for relevant chunks will be retrieved. So that's what's going to happen in this particular similarity search. And also like let's say if the results, if there are no I mean similar context in the vector DB, like we'll do a check on that. If the results are 0, we'll just pass on, like we'll just print saying unable to find matching results. And also like you can set thresholds as well, like so you can set a threshold between 0 and 1. So let's say you wanted only the high maybe the most accurate answer, so that you can define a high threshold. So whatever the relevant, whatever the context which has the similarity score above this particular threshold only will be returned. So you can even define those things as well, like when you're building chatbot. So we'll execute this. And then now we will define a proper prompt time template, and I'll show you how that comes. So as you see here, like we have already loaded the results, I mean the relevant context from the DB. So if you like, let's print it out and see like what are the page contents is being retrieved for this particular question. So for this particular question, let's look at what are the relevant context being retrieved. Right. So if you look at, like I have populated this particular prompt template placeholders as well. So if you see, so in the prompt templates answer the question based only on the following context. And then I'm passing this, the context that we got previously as well. So here is the context. I'm passing this to the template in the placeholder to be placed at. So if you can look at, so this is one of the relevant chunk which is being retrieved. And this is another one. This is another one. Likewise, I think we have set it to 4, right? So we got about 4 different chunks which are related to this particular query. And also, like, I mean, as I previously mentioned, like in the prompt template, answer the question based on the context, and there's a placeholder for the question. So that's being also printed. So, right. So right now we have prepared the prompt with the relevant chunks. So if you look at in the architecture, so right now we had a question, we converted that into embeddings here. And then we also got the topmost relevant chunks from the vector database, and we have concatenated them. So right now we have the question plus the relevant chunks concatenated together. So that's what you are seeing here. We have the question at the bottom, and we have the relevant chunks here. So as you may see, we asked the question about when is the annual plan due, right? So maybe in one of the chunks you may see here, like here, it has the information about the annual plan, right? So this way, like so within the four chunks, the relevant chunks, we were able to like capture the context. So let's pass it on to the large language model and see whether it can pick out the answer for this question. All right, so yeah, maybe I'll give you guys 2 minutes. You can basically like execute the cells and come to this particular point. All right, we'll move on quickly. So I think we have 20 minutes now. So next we will generate the response using Gemini 1.5 Flash. So this is the last section that we're going to talk about, because now we have the question plus the relevant chunks. So right now we'll pass it on to this particular large language model, and we will get the answer, right? For that, let's import this chat vertex AI, the large language model from the LangChain. And let's define the large language model. So from this particular chat vertex AI, we will define the model, like which model that we are going to use for this particular the response generation part. So we will define the model. So we have defined it as Gemini 1.5 Flash. And also there's another parameter temperature that we can set, because the temperature here defines that the responses are being deterministic or creative. So the temperature ranges from 0 to 2. If you set the temperature to 0, you will get the more accurate deterministic answer. So if you set it to 2, it will be more likely to give an creative, a generative kind of an answer. So right now, since we mostly focused on the accurate answer based on this particular document, so we'll define it to 0 to give an deterministic answer. So here we can pass, we can pass the tokens, like we can pass the maximum retries, like how many times it has to retry in order to get a successful response. So and so on thing. So we can pass it on, and we will execute this. Right. So we have loaded the LLM, and we have passed the prompt also. Let's look at the response that it gives. Right. So if you look at, it gave us the response. The annual plan for IEEE student branch Sri Lanka is due no later than 1st of February, right? So this is actually from the document, because we have already seen here as well, 1st of February, right? So this has come from the document. If you go to the document and see, you can see this particular chunk over there. So here you can see the advantage of using the rec, right? Initially, like without the rec, we have asked the same question. You can see, yeah, if you can see, when is the annual plan? The same question we asked before the Vertex Gemini. Since it's not aware of aware of this particular thing, so it said it doesn't have the answer. But since now we have built the RAG chatbot, and for the same question, it answers based on the knowledge base that we have created. So this is the beauty of RAG chatbot. Yeah, so that's about the practical implementation of it. So you can either even ask some other questions also, you can ask and do it. So we have defined some other functions also later. I mean, I have combined all the steps down in the next cell, and I've created a kind of a chat window. But I think with the interest of time, we will move on. But anyway, we will share the notebooks with you. You can go over them maybe after the session. So that's about the hands-on session on RAG chatbot. Maybe I'll give you a minute to finish and come to this stage. Then I'll give you guys a minute and we'll move on to the presentation.
Yeah, then maybe let's take a couple of minutes here for everyone to sort of implement everything. And if there are any questions,
all right,
to ask about that as well. And then you guys can raise if there are any questions or clarifications that you want to discuss. You guys can raise that now. Yeah, we will share the notebook soon after we are done with that. Done with this, Omid.
Shall we continue?
I think everyone might be following. You guys want another minute to catch up, or are you guys all good? Yeah, I think we can continue. I think looks like everyone's okay.
All right. So the hands-on the RAG chatbot workshop, I mean, the implementation that we did before. So that is kind of the basic version of RAG chatbot, right? So if you look at an industry standard at an enterprise level, we have to look at different things in order to create a particular RAG-based chatbot. We can't just directly create it based on the principles. We have to have a certain governance processes around it. We have to have some workflows and so on. So maybe in this particular slide, I will talk about the enterprise standard RAG implementation. So think of it as an enterprise level. You might have so as per the documents, you might have maybe confidential information in the documents for your company. So if you wanted to create a chatbot like that, you can't go and directly import all those documents into the knowledge base, right? I mean, let's say there might be few documents that will be only being accessed by managers. There might be some documents only being accessed by the other employees and so on. So in that case, we can't directly upload the PDF, the all PDFs or all documents, and create a chatbot around it, because now the confidentiality is not there. So everyone has access to all the documents. So that for this particular purpose, there should be a governance process around it. So if you think of building an enterprise standard RAG implementation, we have to think of building a document management portal, for you to upload and manage documents. So in case if you feel you need to add a particular document to the chatbot, you can basically upload it and manage it. Even with time, there might be some documents become irrelevant, right? I mean, we will have newer versions of documents, so we have to incorporate them into the chatbot and so on. So we have to have a management portal. And also another thing that we have to make sure is there shouldn't be any confidential information or any personal information within those documents, right? So if we have them, maybe in an enterprise level, if we have any personal information, or if we put it across the chatbot, which is being accessed by everyone, then then the confidentiality is not there. So everyone can access the other's personal information and so on. So we have to build the PII, the redaction job over there. So that means, here the PII means personally identifiable information. So we have to use this PIA and sensitive data redaction. So after we are uploading the document, we have to run this particular the PIA redaction workflow. So this will go on and read the documents, and if there's any PII information or confidential information found in the documents, basically it will highlight it. So we should be aware that no sensitive or personal information is going into the chatbot or in the knowledge base, right? So it will highlight, and we will remove those documents, or we will remove those particular the personal detail, the content over the documents, and then we can do the same process that I mentioned before to create a record. Maybe you will do the document chunking, create embeddings, and then you will store them in the vector store like we have used previously, the Chroma DB, and so on. So, and also in terms of accessed by user, since I already explained the flow, I'll quickly go through it. Like for all the employees to access at an enterprise level this particular chatbot, it's better if we can integrate it to some of the channels that others, the interfaces that employees are using, right? So we can think of it integrating it to Microsoft Teams, so Slack, so we can integrate the chatbot. So they can ask a question. It will follow the same process. The question will be converted to embedding, and we will search for the relevant information. We'll do a semantic search over the vector store, the database, and we will create the prompt with the relevant context plus the question, and we will call the Vertex AI model to generate the response, and we will show the response in the channel, one of the channel, maybe Teams or Slack. So this is about it. So for this particular PIA redaction job, you can use the sensitive data protection. I think Google has its own data loss prevention API. We can set parameters like if you want to redact any personal names or email addresses, phone numbers, or maybe salary details, like that should be confidential. So even those details, we can redact it. And after the redaction, we can upload the documents, and we can build an interact-based chatbot at an enterprise level. So this is how it's being done at an enterprise standard. And so that's about it. So I'll pass it on to Purnima to talk about more about the prompt management and the different techniques. Over to you, Purnima.
Okay, thank you. Hope I'm audible. Sure.
Yeah, Purnima, we can.
Yeah, we can hear you, bro.
Can you see the screen as well, right?
Not yet. Yeah, it's coming up now. Yeah.
Okay. So now that we've gone through why and how we need to use RAG, so this part comes in although we use RAG, sometimes we need to instruct how these models need to give the certain output. So although we give the information and we expect a certain output out of the information, so what happens is with an existing knowledge base, we add another knowledge base.
Sorry, I think your cam's not getting picked up.
Sorry?
Your video is not getting picked up, I think.
Okay.
And you toggle the safety filter. Yeah.
Sorry.
Yes.
Ah, there you go. Nice.
Okay. So as I was saying, sometimes we are using an existing knowledge base and we are adding another knowledge base on top of it. So these models might give information out of the existing knowledge base as well as hallucinations. So we need to know how we clearly instruct this model. So so the sky is. So if I ask this from anyone, what would your answer be? So it's a very vague statement, right? So we can have the sky is blue, the sky is sunny today. We can have multiple statements. So it's very vague, right? So similarly, a large language model is like a human brain. So whatever we instruct into it, only we get out of it. So we have to know how we instruct these models, and prompts come in handy there. So prompt engineering is where we properly structure and define how we need to instruct this model. But one important thing we need to know is, as Thiru mentioned before, you all added these model configurations, right? So every prompt relies, they are not independent. It always relies with a certain model configuration as well. So we set multiple model configurations like temperature, top P, top K, but like to give you a certain, so I probably a lot of people know this, but I'll just give you some context. So how a large language model works is this temperature, when you set it to a low value, it's deterministic. So how that works is in a model, we save these different multiple billions of parameters as information as token. So what it will do is it will take the, when you give a certain context, it will take the most probable, next most probable token and give it as a response. So when you give a very lower answer, lower temperature, what you ask the model to do is give the highest probable token that matches the context and give the answer. So when you give it to a higher value, you decrease the probability. So top P and top K means it's a subset of temperature. So what it does is it takes the highest probable, it takes a subset of the highest probable tokens, and then out of that tokens, it gives the most, like it ranks and gives the most probable answer out, token out for you. So other than these three, so these are like general model configurations that you can set. So there are other additional configurations you can set as well, like stop sequences, frequency penalties, and presence penalties. So stop sequence is where you define like at what instance you need the model's response to stop. For an example, let's say you want the models to stop giving responses after a certain keyword, like let's say we are trying to get weather data, and after like the weather data comes, you want to stop. So you say like after a certain keyword comes, you ask the model to stop giving responses. And frequency penalty and presence penalty is like if the same response is repeating within a response, like same keywords are repeating, you can give a frequency penalty to this so that you get more diverse answers. And then presence penalty is a one-time penalty that you give if in an existing response, if this certain keyword is there, there you add a penalty. So why I mention all of this is you might instruct your model to give certain outputs, like I want, like for example, complete the sentence, the sky is. So it might then give different, like the sky is blue. So if you set a higher temperature, it might give very creative answers. If you give very deterministic, like lower temperature, it will give more deterministic answers. So all your prompting is dependent on your model instructions. So that's why I added this slide to so that you have an awareness about when you are prompting these models to test it out with different model configurations to identify which best prompt suits your model. So like when we are prompting, like we can set three main different roles onto a prompt. So like one role is a model, so you can call it as assistant as well as model. And then there's another role called system, and then the user, that is who gives the input. So where this assistant and model role comes in handy is if you are like having a chat-based scenario. Let's say you're building a RAG bot where you have a chat-based scenario where you're getting information out of your out of the knowledge base that you've uploaded, like the documents that you've uploaded. So, but you need to maintain context of the previous chat. For example, let's say I am uploading some, let's take the example that Thiru took, like the IEEE document. So I'm asking like what IEEE stands for. And at the next time I'm asking what is its policy for like membership enrollment. So when we say it needs to pick up the context that we are talking about the IEEE. So at that type of instances, we can get the model responses, like give the model response as a model response and say this is the context that we are talking about. The system roles we add like for things that we generally define within a model, like repetitive things. For an example, if we want to ask questions out of a document, we can add a system instruction saying like, provide answers for the questions asked by the user based on the document uploaded. And on the user prompts, you don't have to define like provide answers on the document above. You just can upload the document and then say, ask the question and it will provide an answer. So that is where system instructions. And then the user instructions are how you want the model to behave, like how the user wants to interact with the model. So when we are defining these three roles, then we also have to keep in mind about some elements we define on a certain prompt. So one thing is we have to clearly define the instruction from the model. So that is by using like keywords like write, analyze. So these are like keywords already embedded within the model. So it will pick out of these keywords and it will identify like this is what it needs to do. So like be specific and use like direct instructions. And then you can use like how existing like keywords like analyze or like write or like those type of instructions you have to properly define. Then the second thing is the context. You have to define the context of what type of output that you want out of the instructions. And then you have to define the input data, and then the output indicator is what type of output you're expecting out of the model. Like if it is a JSON output, the JSON structure. If it is a text output, how the text output needs to be. So those kind of things you have to define within a prompt to get the best answer out of the prompt, out of the model. So so I'll talk about some guidelines because we talked about these instructions, outputs, and things like that on the previous slide. So when we are defining these instructions, there are two main ways we can define. Either we can define it as an instruction so that the model picks this out as an instruction by these hash keys, or you can have like double quotes. And then, so one thing I need to say is these are not like definitive things that you need to do. These are like things that people have tested. So there might be better ways to do things. So these are not but like definitive things that you need to do, but these are guidelines you can follow to get a better output out of a model. So normally, like what we do is we like for a model to identify a certain instruction as an instruction, we like define it as these three hash keys or like double quotes and give the instruction like below it so that it knows that this is an instruction. And then after that, you can below it, you can give the certain input that you want for the instruction that you need to do. So for an example, like this is translate the text below to Spanish because we have added the keywords in text. So then what we do is we like for the model to identify where the text is, we have this text keyword, and then we give the text that we need to translate. So what I want to say is instructions need to be clear and specific, and then you can define these instructions in these formats so that the model will know how to identify an instruction. The second thing is avoid impreciseness. So avoiding impreciseness is don't give like vague statements like the one we said before, like the sky is, because even if we ask it from a person, the sky is, they will say the sky is blue. Another person would say the sky is blue in the daytime and the sky is dark at night. So there might be multiple answers that you get. So you need to be very precise of what you expect out of the model. So for an example, if you take the right-hand side, you can see explain the concept of prompt engineering, keep the explanation short. So when you say keep the explanation short, the model would not understand like how many sentences to have. So when it says only few sentences, one sentence can be a few sentences, 5 sentences can be a few sentences. So there's no definitive way to understand what is being expected. And don't be too descriptive. So these are all very imprecise, and the model might not understand what exactly is being expected. So, but if you take the right-hand side, you can see use 2 to 3 sentences to explain the concept of prompt engineering to a high school student. So when it says 2 to 3 sentences, the model knows, okay, the user is expecting a 2 to 3 sentence output. And then it says when it says high school student, the model knows, okay, so here we have said, and don't be too descriptive. Then when we says to a high school student, model knows, okay, a high school student wants these type of information. So I need to give these type of information. And then you get that type of information out. The next thing is avoid saying what not to do to the model, but instead what to do. Because when you give negative prompts, sometimes you might not get the exact answer that you're looking for. For example, like do not ask for interest, or like do not ask for personal information. So like when you give negative prompts, so what happens is in LLM, most of the things are tokenized and it's broken into tokens, right? So do not ask for interest. Sometimes the model might not be aware of the context. So like if you give it like it should users for their personal preferences or avoid asking for personal information, that is you're instructing the model what to do, like not to ask for personal preferences. So like these are like some guidelines that you can follow when you're developing a prompt so that you get the best output out of a model. So then I would also like to talk about like some techniques that you can do for prompting. So one thing is we can like fine tune models, like Yasina will speak about it later, by giving certain information. But if you don't have the capacity to do it, you can do it on an existing LLM itself using a certain prompting technique itself. So one is a few shot prompting is that example. What you do is you train the model how you need the expected answer out. So where you give the question and then the answer. You give the question and then the answer, and then you give the question and it will understand what type of answer it needs to give out. So for an example, here it says, this is awesome, this is a negative statement. This is bad, this is a positive statement. Wow, that movie is red, that's a positive statement. So then once we ask what the next statement, it will understand like, okay, they are expecting the sentiment out of this statement, and it will give the sentiment out. So this is called few shot prompting, where we give like demonstrations and examples before you give the question or like the required instruction from the model. Then the first one is zero shot prompting. Zero shot prompting means you just give like the instruction, and then you give like the input and then the expected output, and you expect the models on the existing knowledge of the model to give an answer out. Then there are multiple techniques you all can search on Google, so I didn't try to put all of them here. So I think Pasindu also talked about it before, like there's something called the chain of thought prompting. So in chain of thought prompting, what we do is we teach the model to think. So for an example, let's say we want to get the odd numbers of a certain sequence. So we first give an example of a number sequence, and we say first pick out like like how can I say, like we can give like the even numbers are 2 and 3 in this sequence, and then in the next step we can give like this is the number sequence, and the odd numbers are like these and this. Then you give the next sequence, and then it understand, okay, so you create like a thinking process of how the odd numbers need to be picked. So I've added another prompting technique here called React. So in React, what happens is we give like React is a derivation of chain of thought prompting. So here what we do is React means reason and act. So there what we do is we create reasoning and then the acting part, as well as the observation part of how we need to do a certain thing out of a model. So for example, like here it says, I want to make a sandwich, so I need to check if I have a recipe. So we give the act part, that what the model needs to do. So search for the recipe for sandwich. So like to search for a recipe of a sandwich. Then the observation is the expected output out of the model. So then we get like, to prepare sandwich, I need an onion and prepare. So what we do is we give like the thought that we want to get, like the instruction we want, and we also give how these need to be done, like the act it needs to do to get it. For an example, we had this recent what do you call use case that we were doing. So there, what we did was we needed to create an image. So there, what we did was we told like there was like we had to create an image of like food. So we told the model like, go and identify, search and identify what are the best type of food you can create from these ingredients. And then we gave the model to say, these are the types of what do you call food, like food plates you can make. So create images for this. So those type of reason to act prompting, those are like different techniques. So there are multiple techniques. You can go on Google and search. So use one of those techniques. You can use one of those techniques also to get a better output out of the model. Then we have these things. So these came into light recently. At the beginning, these are not there, but now like with people playing with GenAI models and they are coming into enterprises, now they have like standard frameworks coming out as well of how we need to structure these prompts. So I've added 2 frameworks here, but again, there are multiple frameworks like RSCF, then we have like RISE, and then I've added here Focus and Ryzen. So these are like structuring how you need to structure your different prompts. So like what Focus framework means is to define a clear function. So this Focus framework can be used for mainly if you have like a certain goal-oriented, like if you need to use an AI model for certain goal-oriented responses, for an example, to analyze a certain thing, or like where there's less creativity, you can use this Focus framework mainly. So like in this Focus framework, we have the main function like function, objective, context, utility, and specification that we need to define. So we need to define a function that is the purpose of the prompt, what you need the AI model to do. Then we need to define an objective, that is what you're expecting out of the model. So these can be the certain response schema that you want it, if you need to the certain output that you want, then the steps that you need to follow. The objective is that. Then the context is like you can give like background information to the certain objective or the instruction that you want to follow through. And then so utility is like how you would use the response and how you want the response to come out, so that this response would be used in this way, so that the model knows to exactly give this response in a certain structure. And then the specifications are the requirements out of the response. For example, like I mentioned before, like if you need it in a JSON format, the JSON keys, the length, how you need the data type format. So those kind of things can be defined on this specification. So in the Ryzen framework, what we define is this role, instruction, steps, end goal, and narrowing. So a role is we give a role to the AI model. For an example, like let's say they are like our goal is to create a blog article. So we can give a role like you are an experienced journal article writer with 20 years of experience. So you make sure the model thinks in that aspect. So you give a role. Then the instructions are what you do is you define like what you want to get out of the model. So for an example, our instruction could be to write a journal article about prompt engineering. Sorry, yeah, write a journal article about prompt engineering. That can be our instruction. And then our steps could be how we want the model to write the journal article. So we can say like first give the title heading, then first talk about what prompt engineering is, second talk about how to use prompt engineering, why we need prompt engineering, different frameworks of prompt engineering, then different techniques. So we can define the steps of what it needs to follow. The end goal is what we need to give. So we can say like we need a journal article with at least 3 paragraphs, with each paragraph having around 5 to 6 sentences, and then so those type of end goals that you can give. And then the narrowings you can give like constraints and limitations. Like for an example, we can say avoid giving like jargon words, and then avoid repeating the same word more than 3 times. So those kind of narrowings also we can give. So those are the limitations that we give the model, so that these responses do not like stick into these constraints. Yeah, so that's about how we need to do prompt engineering. That's about a small thing about prompt engineering, but it's very deep. So I'm not going to talk about like going into deep. So we can talk about like different other techniques and frameworks as well. So I'll just talk about this. Why I've added this is mainly to show you how in an enterprise organization we handle these prompt management, as well as there's another part called model configuration. So in an enterprise, we might have multiple applications. So we need to govern and standardize how these prompts are working. So we bring in this concept called centralized management. If you take a look at this left-hand box here, you can see centralized prompt management, where we, for all of our GenAI applications, all of the prompts are handled through one specific system. So all of the people need to add their prompts there, and it will be managed there. So there, what we've done is we've given them the opportunity to select a framework, and based on the framework to populate their prompts and test their prompts, change the model configurations based on the model configuration to test their prompts and change their prompts. And then we also ensure like the things that we need to keep in mind are when we are defining a prompt, we can't add any like personal information. So we have to be mindful about adding personal information to a prompt. Like we can't say like get me the details of blah blah name. So those kind of things are not standard ways to do. So we don't add personal information in a prompt. Then the second thing is the we need to manage also like certain inputs, how they're coming in, like Thiru showed before, like how we need to redact for certain information or PI redaction. So all of these things are handled through the centralized system. Then Gemini has introduced a new thing called a response schema generation, and recently where now we don't have to. So previously, like I mentioned here, we need to define like the end goal, like what you need, like the JSON output and all. But now, so these are like these are for Gemini I'm talking about. They have defined this thing called response schema, where we can define the JSON output that we're expecting out of the model. So those kind of configurations to do, we've introduced these centralized prompt management and configuration. Yeah, so that's it from my end. Any questions?
Yeah, there's no questions on the chat so far, Punya. Maybe we'll move on to asking the section, and then at the end we'll take up some questions on this section also.
Yeah, I saw a bunch of questions on the slide. I think we can take a look at it after.
Sure, yes.
Okay. Let me share the screen. Right, can you guys see my screen?
Yes, Indra.
Okay, cool. All right, so I think Thiru gave a really good explanation on RAG, and Purnima explained everything to do with prompt engineering. And one thing Pasandu also mentioned was how we can fine-tune LLMs. So that's exactly what we're going to dive into in this particular piece. So let's just get right into it. So fine-tuning LLM is basically what you do when you want to train a pre-trained model to be good at a specific task. And let's say ideally like a very niche task where you can't expect every single model to have awareness about. So that's the sort of reason you try to go into LLM fine-tuning. So this flow summarizes it like pretty greatly, I feel like. So what happens is all this like ChatGPT, Gemini, their corpus they're trained on is massive, and the chance of us getting to replicate that is almost non-existent because they have a huge data set. And what they do is like they grasp out all the general information they can. This includes stuff like math, coding, general knowledge, and all that kind of stuff. So that gets encapsulated into what's called the base LLM. That's what you use when you use ChatGPT. But sometimes it's not good enough for a very niche use case. So what we do for that is that's where we use fine tuning. Basically, what you do is you create like a very domain specific data set. This can be something to do with your company or like some sort of personal information ChatGPT might not know about you. And there's a way you structure it. You'll see all that stuff in the demo. And once you have the structure, you can use that to fine tune LLM. It's a lot easier than it sounds. I mean, arguable, but it's not an easy thing to do. It's not like a very straightforward thing. But I'll try to make it as simple as it can be on the demo. And what we get out of that is the fine-tune LLM, and then you can query that like you would with a base model. So there's a bunch of pros and cons here, much like everything. So the pros is the fact that you can it's very suited for your domain. So there's the chance of it hallucinating is almost I can't say zero, but it's quite low because it's trained only on that specific data. It does have some memory of what it used to be, but now it's very fine-tuned for the piece that you trained it for. And you're going to have like very consistent outputs because you define in your data set what sort of inputs and outputs you want to have. And most of the time it will abide by that. And improved performance of RAG, again, arguable because RAG does perform quite well in most reasons, but because it takes that semantic understanding of the top end results, there's a chance that it might give out the similar results, but it's not exactly the exact answer you want. So again, if you have a fine-tuned LLM with enough data and enough resources, you can get a really good model out of it. And it's also like very less reliant on external data. It doesn't have to worry about the internet anymore because you already trained it on the data you want it to be trained on. And so yeah, just like I mentioned before, it's quite good at handling those niche segments. So the chance of it responding for edge cases are also really great. Of course, there are some cons you can't really ignore. The first is the fact that it's very resource intensive, meaning you need a very good GPU to train them. But there are frameworks that came out recently, certain algorithms that help you do it with your own machines. That's something we'll get to later. It can be time consuming. Even the model I'm about to show you guys today took around 5 hours to train on the basic GPU, but with Colab Pro, it came down to around 20 minutes. Chance of overfitting is really high. Again, you're giving that small data set and then you're trying to get it to train on that. It works for the betterment for some people who want like very specific results to come out, but again, arguable. And the knowledge will be very static because it will only know the data you gave it. And if you want it to improve, you'll have to keep retraining, and that again costs more and also more time. So yeah, it works great for niche data sets that RAG might fail to do. But so we'll take a look at it. And before we get to the demo, let's try to understand how we can train an LLM also. So there's 3 major ways. There's a lot more that came out recently, but these 3 are still the basics. So full fine tuning, this one is basically something we'll never get to do unless you have a supercomputer lying around at your house. But yeah, basically what happens in this is you try to train all the n billion parameters in your LLM. This is, I mean, great if you can do it, but it's really difficult to do. And basically what happens is every single parameter you train goes directly to the base model. You're not changing it at all. So it's a direct updates from the optimizer to the base model. And the second thing is LoRa. This is low rank adaptation. This is a very popular algorithm nowadays, and this is used by a lot of developers. So basically what it does is it brings in an adapter, and this adapter layer, what it can do, it can freeze some layers, and then only the weights in this particular adapter layer are then trained. So you basically ignore all the billions of parameters you have in your LLM, but you just focus on the parameters that are in the adapter. So you train those, and that saves you a lot of parameters to train, and therefore cuts down your the costs and also how much you want to train. So the number of trainable parameters drops a lot. So that's on LoRa. And after that came QLoRa, which is a variant of LoRa, but happens in a very quantized level. So the whole point of that is to load in a model as a bit lower than what it's supposed to be. So generally LLMs come in 32-bit. Not sure if 64 is out, but generally 32-bit is what it's supposed to be. So what you do is you break it down into a 4-bit. We'll get into detail as to what happens when you do this, but essentially you lose some sort of precision. So you're dropping it from 32 to 16 or 4 or 8, whatever that can support your resources. So by doing this, you're also cutting down the set of parameters you'll have to train, because you're no longer worrying about each of those precision. You're just focusing on the whatever bit you chose. And you also introduce paging in this. So what happens with paging is that if you're not training or if you're not loading in a piece of the LLM, you just ignore that part for now. So you're only loading like a piece of the LLM, which you're training, and the rest will be offloaded. But you basically traverse and then you load whichever one you want. And that's what paging allows you to do. So it's like a less resource intensive way to train a model. So we do have a demo on this. Let me share that with you guys. I think this one won't be as straightforward. So I'll be sharing the document directly with you guys. I mean the notebook, but you guys can follow along as we do it. All right. All right. Can I get a confirmation again that you guys can see the screen?
Yes, Indra.
Okay, sounds good. All right, so I've shared the notebook with you guys. Did you guys get that, Prasanna?
Yes, we
Okay,
can see.
cool. So again, I'll go through what's needed to learn this as a beginner, but feel free to read the comments I've mentioned in the notebook and just drop any issues you have even in the GitHub. That's completely fine. I can get back to you guys. Right, so we'll be using Colab for this. And the reason why is because you can just install your environment here itself. There's no need to install anything on your local computer. So again, I'll keep this as simple as I can. But yeah, let's just get into it. So we'll be using LoRa for this, the low rank adaptation. And so fine-tuning an entire LLM is not easy, as I mentioned before. So we'll be loading this in as a 4-bit. So we'll be using the Llama 3. We'll be using the Llama 3 model, so Llama 3 8 billion, but we'll be loading in as a 4-bit. So over here, I'm just installing the libraries we'll be needing. So Onslaught AI is something I'll need to mention. It's a package we'll be using because it essentially increases your training time by decreasing the percentage you'll be decrease the percentage of memory you'll be using for your training. So we'll be using Onslaught AI as our main thing here, and obviously Hugging Face. If you guys aren't sure about what Hugging Face is, it's basically it's an open source repository which has a set of models, data sets, spaces. You can collaborate with other developers and create your own LLMs. It's not just restricted for text. It has images, audio, video, what have you. So yeah, let's get started with that. So it's a few things to mention here. Again, I'll keep it very brief. And we'll be using, I saw a question before asking how will we be training the LLMs. So we'll be doing it with performance efficient fine tuning, and the algorithm we'll be using is LoRa. So previously I spoke about how QLoRa can quantize LLM. So what does this really mean, and how does this save memory? So if you were to take a regular LLM, it would have things in float 32. And so basically every single calculation you do when you're trying to do some sort of inferencing is handled in 32-bit. This, in the billions of parameters you have, leads to a almost exponential burnout. So what you do is you take it down into n bits you want, so 16, 8, 4. Of course, this comes to the trade-off, because every time you decrease the bit size, you're also compromising your precision, but you're increasing the runtime. So it's faster to load, and it's easier to do the training. So for this case, I'll be using a 4-bit one for the sake of the demo. Yeah, so there's a few stuff here to know. So again, as I mentioned before, LoRa does its way by creating its own adapter weights, and you only focus on fine-tuning those weights instead of all the billions of parameters you have in an LLM. So what I've done in this is I've created all the configurations in this particular cell. So the cells after will only focus on training the model. So if you were to refer to anything, you just have to come back here only. You don't have to understand what everything is doing in between other cells. Yeah, so the way it works is you need a few things to train a model. So you'll first need a pre-trained model. In this case, we'll be using the Llama 3 8B instruct, and will be loaded in 4-bit. And you also need a data set, which you're trying to train it on. So I chose the medical data set. So you can find all of this in Hugging Face, but this is specifically the data set I've taken. So the reason why I want to fine tune on this is because if you ask Llama 3 8 billion any sort of medical question, it will most likely give a decent result. But this data set consists of very granular details that it tends to miss out. So that's the whole point of fine tuning in, because you want it to be able to take out that edge cases or that 10% that you want the model to train on. So we'll be training it on this. And the thing when you're training a model is that you need to, so each LLM will have its own syntax, which you'll need to use for training. So essentially what I've done is all of these 3 columns you have in the beginning are then transformed into what's called a prompt column. And that will have the system instructions and all the templates which will be needed in order for the LLM to understand what you're trying to train. So it's just the same stuff you have here, but we have a start head ID in the system and head ID, and then your input and then your instructions and so on. So this one I've taken directly from this user, and that makes training a lot more easier. And yeah, so we have the base model, we have the name of the fine-tune model, and we are also given the data set we'll be using. And there's a set of parameters here. Again, not everything is very important, but I'll just go through the stuff that are somewhat important. So max sequence length just refers to how big of an input your fine-tuned model can take in. So in this case, 2048 is the maximum token size it can take in. Anything beyond that is not allowed. I mean, you can train this, but you can adjust this. But again, keep in mind that this will use your resources quite a lot. And I'll be loading it in 4-bit. And so now we get to the LoRa configurations. So the R basically refers to the number of LoRa layers you have. The more you increase this, so this can also be in powers of 2, so 16, 32, 64. But just keep in mind that the more you increase this, the better it will learn, but it will also increase your resource usage a lot more. So target modules, not that important, I'd say, but alpha dropout works a lot like convolution neural networks. But feel free to drop any questions later on this. And these are just other fine-tuning algorithms you can use. We won't be using them because we're using the base LoRa algorithm. So the training data set, as I mentioned before, and the input field is basically the transformed, how can I say this? It's the transformed column we have used here. And there's also another set of training configurations you'll have to give. Again, not everything is important, but something revolutionary here is the Adam W optimizer, which used to be Adam back in the day, but this is like a more optimized approach for LLMs. Yeah, so you don't have to worry about all this stuff. If you're just training your custom data set, feel free to use the notebook with probably the same configuration, just change your models and it'll work completely fine. Yeah, so after that, what we're gonna do is we're gonna go into loading the pre-trained model and the tokenizer. Again, both of these exist in Hugging Face. So the stuff you mentioned here is basically the base model I'll be using over here. So I'll be loading that in, and when you load that in, you'll also be loading in the tokenizer, because that's essentially the way an LLM can encode and decode human text into what they can understand. So it's important that you load both together. And yeah, then we get into LoRa and basically our parameter efficient tuning algorithm. So I feel like I'm going over this again and again, but just keep in mind that we're only focusing on a few parameters we added with the adapters, and we're not worried about the entire LLM parameters, because that's not going to be possible to do. So yeah, basically just pass in the training stuff you had from before, all the configurations from before. They'll be taken in from the PEFT model. All this comes from Hugging Face, so you can just directly load in the configurations. And next you load in your training data set, which is the one I showed here. And after that, you can fine tune it using SFTT trainer. So that will just do the training. It'll do all the handling of data for you. I think this is also by Hugging Face. I might be wrong here, but again, makes your training a lot easier. And so yeah, after you can just trigger the training. So again, as you can see, Onslaught makes your training a lot faster here. It actually managed to do it in 17 minutes. So another key important thing, key feature here is that we were able to train 41 billion parameters, and this is only taking it in 4-bit. So you can imagine how high it's going to be if you just loaded the entire thing. And also what's important here is like if you're used to training general models, you know that your epochs will go up to like 100 or 1,000 based on what you're trying to train. But in this case, we only had one epoch, and that epoch is split into 250 steps. So that's how difficult it is to train a model, train an LLM. So it actually went through the entire data set. I haven't used a lot, by the way. I think I only have 2,000 rows in my data set. And that itself was broken down to 250 steps. And that's just one epoch. So you can check how your training loss went down over time. That's ideally a green, that's a green light for your model. So, and you can also see what sort of stats. It'll be stored in a JSON, but if you are too lazy to see what the JSON looks like, it looks something like this. And so finally, what you can do is you can save the model, and you can also push it to Hugging Face. And this makes it very easy for you to make inferences later, because as long as you have it on Hugging Face, it's free, by the way. You can just make inferences out of that using the SDK. So in this case, I've trained it, I've saved it locally, and also I've done a push to Hugging Face. So in this part can be a bit overwhelming because we have a different set of quantization strategies. But again, it's up to you, completely up to you how you want to save your model. So I've saved it in 16-bit because Colab Pro allows me to easily load that in and make inferences. But based on your resources, you quantize as much as you want. Just keep in mind that it's a trade-off between runtime and precision. So yeah, so that's what you get. And after that, I'll be loading the model locally for inferencing and testing. So now what we can do is we can try one of those very niche medical questions on the model that we had trained. So that would look something like this. So we had to stick to the same syntax or schema we had for each LLM. So for Llama 3, it's to follow this approach. It's the instruction, and then you give your instruction, and then you have to close instruction. So the question will be this, and it would output again. By the time you follow this notebook, when you reach here, your GPU is going to be overflowed. So you'll have to disconnect your runtime and then just continue from this part only, and that'll be completely fine because you have the model loaded in locally. So yeah, and then it'll give you the answer, and this is very specific, and it's actually very close to the answers you have here. It's almost quite similar. It's the same context, but just answered in different ways. So you can ask very specific questions over here. And yeah, that's basically how it works. This set of different questions I have asked. You can also do a comparison yourself by asking this from general Llama 3, 8 billions 4-bit, and also on the medical one we've trained. And if you guys want to access the model directly, you can just go into Hugging Face, and you can get it from here too. Sorry, let me just send it here. You can get it directly from here. And this is another reason why Hugging Face is used by a lot of developers, because you can just directly start using your model from here. And yeah, so that's basically how it works. There's a lot of use cases for doing something like this. specifically if you're working with legal documents, or like there are specific clauses that you have to return when a question is asked, it probably the best option is to fine tune an LLM. It can be resource intensive, can take a lot of time, but it guarantees really good results as long as you're not worried about having quick real-time updates going into your system. And yeah, so that's a little bit about how we can fine-tune LLMs. I hope I kept it a bit simple. I know there's a lot in it, but you can ask any questions you want, either on the time we have now. I think we have around 20 minutes left for questions, or you can just drop them on the GitHub we have later. So yeah, that's all I have for you guys.
All right. There's one question on the chat. Yes, in the instead of prompts can't be trained by using instructions which are on the data set. You take that up.
Yeah. So we can do that. I think let me just show that here. So generally, what you'll do is you'll have to embed the instructions. Let me just share the screen again. So this, yeah. So sorry, who asked the question?
It was
Question.
done.
Okay, so yeah, you can do that, but it's going to be a part of your prompt. So you can't just give the instruction because it needs to, so you'd have an instruction and then the input and then what sort of output you're expecting. So generally what you'll have to do is you'll have to append all of these three things into one text called the prompt. You can change the name, it doesn't have to be the prompt, but it's generally the best practice people follow when training LLMs. So this will basically consist of this, and that. So it'll have the instructions and also using that specific instruction, what sort of input and output mapping you want to have. That's basically how it'll work. I hope that answers your question.
Yeah. So I think if there's any other questions, we can take a few.
Yeah, I think there's another one here. So Dinuk has asked, after we fine tune a model, how can we use it in a production environment? Yeah, that's a great question. So I think the approach I've shown here is more of like a personal project approach, because we felt like that would resonate a lot more with everyone here. But if you were to use it in like a production environment, you'll have to use, I mean, you can definitely use something like this, but I'd recommend using something like Vertex AI. They have their own fine-tuned model. But the way training works is a bit different because they take the inputs in a format called JSON-L. But the syntaxes, all of those will follow. But I definitely recommend using something like that because it makes things like retraining, it makes things like data drift monitoring a whole lot easier than you manually deploying it using your own pipeline. They just make it a lot easier. You can also get a workflow diagram created as you do your pipeline. Maybe I can send the link to that too.
All right. We have another question. How to fix a chatbot with Vertex AI Studio, agent plus dialog flow. Right. So this is also something that is available on Vertex AI. So like the framework or the explanation that we did was like a custom way that you can build the RAG-bots. But they also have this new feature called agents where you could sort of automate most of this process, where you can simply create an agent and then they have something called the document stores where you can go and upload your knowledge base. So that could be a PDF document, that could be a website, that could be like unstructured set of data. So you could select the data type and upload that. Then that you can directly connect with Dialogflow. So I think one of the things to consider there is you have to make sure that there's a certain amount of prompting that you have to do. There's a certain amount of prompting and configuration that you have to do there. So basically, there are certain parameters to test in terms of similarity check, whether you want to have like very high level of grounding. When you say high level of grounding, it will only take like very much relevant context in order to give answers. And also there are ways you can give like low level of grounding as well. And there are certain other prompting that you can do around it. So I think there's a bit of tweaking for you to do there, for you to get the right thing out. But I think if you get the right prompt and the right level of grounding in, you should be able to get it out. I hope that answers your question. So probably what you have to work on is changing the configurations and working on the prompt. And there was a couple of other questions on the link as well, Slido link as well. So I think one of the questions there was asking about the difference between Neo4j and the vector database. I mean, that's actually also a really good question. So vector databases that we spoke about earlier, that sort of looks at a text embeddings, where you store the text embeddings in the vector store and do like an embedding sort of a semantic search. But when it comes to databases like Neo4j, they are called graph databases, where you don't necessarily embed the data and store them in a numerical format, but you sort of store them as nodes and basically as nodes in a graph, right? So that way, like when you do the querying, you can actually query the relationships also. So there are different use cases this would apply to. Like if you have a use case where you want to make sure like you want to get information with certain relationships also, you have to go for a database like Neo4j and with a graph database. But also right now we are looking at implementations where we are trying to bring out a hybrid approach where we use graph databases and also like vector stores in order to get the optimum results. So those are like mostly based on the use case only, you will decide which database to use, but I think both of them has their own benefits and disadvantages as well.
See another question on Slido, which says, can we increase the max number of tokens a model can handle by changing its attention mechanisms? Yes, but I'm not sure what you refer to by changing its attention mechanisms. I don't think that's a direct way we can do that. But basically, there is a parameter which will also be there in my notebook. You can just change what I put for 2048 into any token you prefer. But just know that certain LLMs have their own restrictions. So for example, I'm not sure, but Llama does not allow something as great as 1 million tokens, but Gemini does allow that. So you don't have to like tweak the attention mechanisms yourself, but if you change the parameter there, they'll do everything for you. Yep.
Yeah, there's another question, Yasin, on the chat. I think you can take that as well.
Okay. Are there any quantized multimodals from Hugging Face you can recommend to run locally on RTX 4050? I've tried a few. Okay. Yeah, I had this question yesterday too. So basically, Geetika, the thing is, inference from Hugging Face, even if the LLM you're using is like, even if it has like a very fast inference like based on its benchmarking, if you don't have Hugging Face Pro, your inferences are going to be a bit slower, and you're not going to get access to most of the famous LLMs. Like for example, I think even Llama 3 requires you to have a if you're using direct Llama 3, you still need a Hugging Face account. So I think it's a combination of both. But if you have a RTX 4050, you can definitely try out certain things like multimodals. Yeah, you can try the new Llama, but I think you'll still need an account for that. I might be wrong here, but as far as I know, that's the way it goes.
Yeah. So I think most of the other questions we answered on the chat as well. Yeah, there's one more question. Yasin,
Sorry, after getting model from Hugging Face, how to connect our application to it? Where do we host the model? Yeah, so after you host it on Hugging Face, it'll exist there. Yes, and then you can use the SDK and you can integrate that into your applications. That will be quite straightforward for you. But the rate at which you inference, those will again differ based on the account you have. But you can get so there's a similar thing to, you can just load up the code for your your trained LLM, and then you can just integrate that into your application.
all right. So I think the other questions, of course, we addressed most of them. Yeah. Any other questions, guys?
Okay, wait, hold on. Can you show a demo with medical to connect with? Oh, okay, sure. Sure if you have time for a demo, but I can just quickly say what to do. Yeah, so if you just go into, hold on, let me just load it. Yeah, I'll just send the code for that. Just give me 1 minute.
Yeah, so while Yasin is getting that up, if you guys have any other questions, I think we can take a couple of more questions. So I think it was very interesting. I think there was really great questions coming in. I think you guys are very invested in this. So I hope you guys are working on generative AI based applications for whatever the projects that you are building for this particular competition as well. So really enjoyed these questions. And if there's anything else, I think we would like to take a couple of more as well before we wind up. So we could share whatever the information that you guys would like to know.
Yep. Oh, I think Nuan, my runtime's just setting up. It'll take a while. So what I can do is I can just append that as a cell to the repo I've sent you guys, to the notebook I've sent. So I can include the last line of code which will do the part you wanted. And there's another question from Tharana. We can train multiple lower adapters to make an LLM do multiple things during inference, right? Yeah, you can do that, Tharana, but the thing is, it's better if you can restrict one data set to do one particular task, because if not, you'll have to give in a lot more data. So if you want to get more than one task done, you'll have to give that much of data more. So it's unless you have like a huge data set, I think what I can recommend is you keep one data set to train the LLM for one specific task. And yeah, Nuan, the thing you sent is correct. That's where you can get the code.
All right, I think we've gone through all the questions. If you guys don't have any other questions, I think we can wind up the session from here. So that's all we had from our side, guys.
Right. Up next, I would like to take a moment to express our heartfelt gratitude to our panelists for sharing their invaluable knowledge and experience with us today. Your contributions have made this session truly enriching. We have a small token of appreciation that we would like to present to each of our speakers. Thank you once again for being part of this magnificent event and for your ongoing dedication to advancing AI. Thank you. Before we wrap up, I'd like to remind everyone that the registrations for the Sri Lanka AI Challenge is closing tomorrow. So if you haven't registered yet, this is your last chance to join us on this incredible journey. Don't miss out on the opportunity to showcase your AI skills and learn from the industry experts. You can now register using the QR code provided in the screen and the link in the chat box, or visit our website for more details. As we have already met with the expected limit of delegates, there won't be any further extensions. Thank you. Now, we would love to capture this moment with a group photo. I know most of us aren't in our formal attires, but if you could please turn on your cameras and join us, we'd love to take a snapshot to commemorate this session.
Is it only us with the cameras?
Seems like so. All right. So, and with that, we have come to the end of today's session. And I want to extend my sincere thanks to all of you for your active participation for making this session a success. Hope you found today's discussion both informative and inspiring. Stay tuned for more sessions as part of the Sri Lanka AI Challenge. We have more exciting sessions lined up, and we look forward to seeing you all again. Have a great day ahead, and thank you for being here.